right, this is going to be the video going over the other practice test, the longer one. It's called Practice Test for Solving Rational Equations and Inequalities. Okay, so here's the equation, and we're going to start it the same way that we started with Mr. Yosef's problems, where we're going to find asymptotes. So the horizontal asymptote is going to be 1 because they have the same degree, and the ratio is 1. The vertical asymptote is going to be x equals 5 because right there, if I plug a 5 in, I'm going to end up getting a 0 in the denominator. Now I need to see where these two functions intersect each other, so I'm going to set them equal. And I'm going to kind of walk through a similar solving process where I get rid of the denominator. Make sure you distribute all the way. And I'm going to get the x's together and get the numbers together. So I have 12 equals x. So they intersect each other at 12. You guys are going to be asked to do a sketch of the picture. I'm going to go by 2s so that I can fit it all in. Okay, so I know that there's going to be a horizontal asymptote at 1, which is going to be a little bit hard to graph on mine, but there it is. Okay, I know there's going to be a vertical asymptote at 5, 2, 4, 6, so 5 will be there. I can graph y equals 2, that's just a line right at 2. Might have to pretend that it actually hits it. Okay, so there's my y equals 2. And then I need to graph this part here. And you are allowed to use a calculator, so I'm going to pull my calculator graph up. I think it's helpful to look at the graph. So I have the graph down here below. And then I also have the equation written here in white so that way I can think about plugging some numbers into it. So obviously they intersect each other at 12, which I can see that here. There we go. There it is. And then it's easy for me to find some key points like the y-intercept. I can find the y-intercept by plugging in 0. So that's -2/5. So it's going to be hard to do on my graph because my graph is so little. So I'm just going to kind of put it out there really close to the x-axis. I also know that if I plug in -2, that is going to give me the the x-intercept because I get a 0 on top. So -2 will be my x-intercept. And so this kind of gives me a couple of points to find this guy. And then up here, I know that these two functions intersect at 12, so I would be okay with you doing something like this. Okay, so now, if I go back to the very original question, it was, where is x plus 2 over x minus 5 less than or equal to 2? So I want to know where it's below the red line. So I'm going to get my highlighter out here. And I can see that it's below the red line here. I'm kind of highlighting it in a light purple, white kind of color. And it's below the line here. So if I write this out as an interval notation, this is -infinity to 5, because that's what that space is. And then here, remember, that was at 12, and it did say or equal to, so it's going to be 12 to infinity. Now, I am also going to ask you guys to make a number line, like graph your solution is what it'll say, and it'll be on a number line. So, let's see. If I go, I'm going to just kind of start here. I need to be including 12 and then shading to the right. There's the 12 to infinity. And then 5 is not included. It's an open circle. And it's going to go to the left. So those are the solutions. All right, this one's kind of interesting because I have a quadratic in the top. I think it will be helpful. We still should probably write down a horizontal asymptote and a vertical asymptote. Now this one, notice the degree is bigger on the top. So when the degree is bigger on the top, there is no horizontal asymptote. The vertical asymptote is going to be x equals -1. Let's figure out where these equal each other. If I multiply to get rid of the, whoa, I don't know what I just did. That was weird. If I multiply to get rid of the denominator, then this is just still 0 because 0 times any of that is 0. So if I factor this, I get x minus 4 and x plus 1. And when I solve it, I get x equals 4 and x equals -1. So it at first maybe looks like they're going to intersect each other at two places, but hopefully you notice for x equals -1, if you go back to the beginning, that was actually our vertical asymptote. So x cannot equal -1. That's an extraneous solution. So they're just going to equal each other at x equals 4. And in fact, graphing this is going to be relatively easy because if I write this in factored form, notice what happens to the x plus 1s. And hopefully you remember, what does that create? A hole. So there's going to be a hole at -1 instead of a vertical asymptote. So I messed up right here when I said there was a vertical asymptote because I should have factored first to see. So it's not a vertical asymptote, it's a hole. And I just get x minus 4. So this is interesting because that's just a line. So if we take a look at the graph of this, here it is. See how it's just a line? And they intersect each other at 4. And yeah, just have a line. So if I graph this myself, obviously y equal, when I say graph it, I want you to graph like each thing separately, so each side. So x minus 4, that equation is going to have this. It's just a line that looks like that. And then the other thing was 0. Y equals 0 here at the x-axis. And so I see that they hit each other at 4. So there's actually a hole there. I shouldn't have colored that in. There's actually a hole there. No, there's not. I'm sorry. I need to pay attention. The hole is at -1. So right here, there's a hole. Okay. So that actually does matter because the original question was, where is that function greater than 0? And it's actually only greater than 0 in one place. Right here. And it did say greater than or equal to 0, so we're going to need to include the 4. So that's 4 to infinity is the answer. And of course I could do that on a number line pretty quick and easily. There's 4, color it in, and shade to the right. All right, moving on to question number 3. This is just a regular solving question, so let's work on getting common denominators. If I multiply x and then an x squared over x squared here, they're all going to have an x squared in the denominator, which is helpful. And I'm going to need to make this equal 0 because I have an x squared. So I'm going to leave the 10x squared over there, and I'm going to subtract the 3x and the 1. All right, so this is going to be a guess and check kind. So that's a little annoying, but it's not the end of the world. I'm going to guess probably 5x and 2x. It could be 10 and 1, but let's try 5 and 2. And then thankfully the only things that can multiply to -1 would be -1 and 1, or 1 and -1. So let's try it. All right, this is negative 2x. This is positive 5x. Okay, so this is close. I got 3x, and I want negative 3x. So I should do 5x plus 1 and 2x minus 1. Like, just change the signs. We can double check and make sure that that works. And it does. So I'm trying to figure out where they actually equal each other. So I'm going to have 5x plus 1 equals 0. Remember, all of this equaled 0. And then 2x minus 1 equals 0. If I subtract 1 and then divide by 5, I'm going to get negative 1/5 is one of my answers. And over here, I'm going to add 1 and divide by 2, and I get a half. And if I look back up at the beginning, negative 1/5 and 1/2 do not cause me any problems. So, like, they don't make anything undefined. So those are good. Number 4. Okay, now remember, guys, there's obviously lots of different ways to solve these. So I could understand if some of y'all would do the cross multiplication thing for this one. That could definitely be a way to do this. I think I'm going to factor these denominators. Okay, so that was a difference of squares. So notice they actually have an x minus 1 in common. So this side just needs a 2, and then the left side just needs an x plus 1. So if I distribute, I have 5x plus 5 equals 30, and they all have a common denominator, so I can just ignore the denominators, and so this one's actually not too bad. 5x equals 25, and if I divide by 5 on both sides, I get 5. If I go back up to the beginning, if you plug 5 in, you can see that it works and there's no undefined values, so we're good. All right, guys, so there's not one on the test exactly like this, where you have to actually write an expression, but I still think that this is a good question. Again, it has to do with rational functions and kind of thinking about context. So you're going to drive this many miles in a year, and your car gets 24 miles to the gallon. Okay, so if I divide these two, this is just going to give me how many gallons I get. And so I'm going to do that real quick. So you're going to need 625 gallons. And then, of course, if you are trying to figure out the cost, you need to do however many gallons times the price per gallon. And that is going to give you, oh, I just lost it. $1,375. Now I could have done that all in one operation, and you guys might have done that. Like 15,000 divided by 24 times 220 to give you the 1375. That might be helpful for part B. So you're wanting to get a new car that gets X more miles per gallon. So you're still driving this many miles, but instead of getting 24, you're getting 24 plus X because you're getting X more. And then it's still you're gonna have to multiply by 220. So that would be an expression that would give you a new thing. This is 220 over 1, so you could actually multiply straight across and have this as your expression for how much money it would cost for the year. Okay, so now I'm supposed to write an expression for my savings. Originally, you were spending $1,375, and now you're going to be spending this much, this expression. So that is how much money you'll save. That's all it is. So it's how much money you spent before minus the expression of what you're going to spend now. And then part D says, suppose you save that much with the new car. How many miles per gallon does the new car get? So this is your savings. and it needs to equal this. And so I'm just going to actually have to solve this. And of course the numbers are not as pretty because you are dealing with a more realistic scenario. So it looks like this is over 1, so I'm going to need to multiply it by 24 plus x on the top and the bottom. And I'm going to need to multiply this one by 24 plus x on the top and the bottom. All right, so I just distributed all of these, the 24 and the x, and then the 24 and the x, and I get this. So it's kind of nice, at least the 33,000s are going to cancel out over there. I'm going to subtract the 18750x. And notice my denominators went away because they just were all the same, so I just kind of ignored them. Okay, and I subtracted the x's. Now I'm going to divide 1187.5 on both sides. And I get 3.79 equals x, which means that the new car gets 3.7 miles per gallon more than the last car. Okay, last question. This one is fun. So this is true that in any triangle, the sum of the lengths of the two shorter sides have to be greater than the length of the longest side. So one thing that we need to do when we look at this is figure out which one of these would be the longest side. So out of those, 1 over x would have to be the biggest one, because if you're dividing by 1 over x plus 2 or 1 over x plus 1, like x plus 1 and x plus 2 are actually bigger than x, so you're dividing by a bigger number, which is going to make the fraction smaller. So if I kind of write this rule down in terms of these sides, it's saying that this side plus this side has to be greater than the length of the longest side. So now I have a lovely little inequality here. I'm going to have to do some multiplying to get common denominators. And this one has a little bit more multiplying than usual because it has so many things. So on the right side, it needs an x plus 1 and an x plus 2. And on the left side, this one is going to need an x and an x plus 1. And then the second one is going to need an x. I have to write kind of down here, and an x plus 2 in order for it to have all of the things. So let's distribute this. And actually, I kind of jumped straight in with some things, and I shouldn't have. Pause for a second. Let's think real quick about the horizontal asymptotes of each of these things. So all three of these are going to have a horizontal asymptote at 0, because if we're looking at the red function, they all have a degree that is bigger on the denominator. There's going to be 3 different vertical asymptotes. So there's going to be -2 for the first one, -1 for the second one, and 0 for the last one. All right. Now, for the moment, I'm going to treat this as an equal sign, so that that's kind of what I jumped in with first, getting the common denominators. So if I multiply this out, I have x squared plus x for the first one. I have x squared plus 2x for the second one. And then over here, I'm going to have to distribute this whole thing out. I'm going to have x squared plus 1x plus 2x plus 2. So 2x squared plus 3x equals x squared plus 3x plus 2. And let's go ahead and try to make this equal 0, maybe. Or maybe not. If that goes away. Okay, so I just made this equal 0. Combine, so I kind of did that fast, but I combined like terms and then I subtracted things to make it equal 0. Since this just equals a number, I'm going to have that, and so I'm going to do the square root on both sides. Don't forget that you get plus or minus the square root. And now I'm probably going to need to just take a look at a graph of this so that I can figure out where it actually is greater. Okay, so you can see that I graphed this. Notice that I graphed the 1x, or 1 over x plus 2 plus 1 over x plus 1 as one of my functions, and that one's blue. And then I have 1 over x as the other one, and that one's purple. So I'm looking for where is the blue greater than the purple. And the thing that's kind of interesting is we have to take context into account here, because notice that the blue is greater than the purple. This little line right here, it's greater just for that brief moment, but that's a negative number, and I can't have a negative side. So the only place where the blue is greater than the purple is over here. I just highlighted it in pink off to the side. That's the only place where it's greater, where it makes sense in this context. And since we know that they intersect each other at plus or minus the square root of 2, then this point right here must be x equals the square root of 2. So this is only true from square root of 2 to infinity. And Zeke was watching me solve this problem. Do you want to say hi?
Hi, I have a cough and I'm kind of sick.
Yep, and that's why we're home. But I hope this was helpful. And I will hopefully see you guys tomorrow. But if I don't, I'll see you on Thursday. Bye.